We've talked about Newton's second law, and now I want to talk a little bit about Newton's first law, which is also known as the law of inertia. So the statement is that an object at rest will remain at rest, or an object moving at constant velocity will continue to move at constant velocity if and only if the net force acting on the object is zero. And so logically, the if and only if means you can assume the premise and get the conclusion, or you can assume the conclusion and get the premise. It's bidirectional. So some terminology. If you have an object at rest, it is known to be in static equilibrium. Static means not moving. An object moving at constant velocity is in dynamic equilibrium. In either case, the sum of the forces, the net forces, is zero. And so the fact that the object is at rest is just a special case, really, of having constant velocity, the special case being v vector equals 0. A non-zero net force causes the object's velocity to change. And so that's the real insight in Newton's laws. It's focusing on changing velocity, which we've quantified to be acceleration. If there are no forces acting on an object, or if the net forces are zero, the object won't change its velocity. So to paraphrase things a little bit, it doesn't take a net force to keep something moving. Now this last part about inertial reference frames in the next slide are a little bit more subtle, so let's see if we can understand that. An inertial reference frame is a reference frame in which Newton's laws are valid, and that sounds very circular, but there actually is some physical meaning here. So first of all, if the acceleration of the object is zero, that's true only when the net force is zero. And if the acceleration is zero only when the net force is zero, then the frame is inertial. So from a practical standpoint, it turns out the Earth isn't a true inertial reference frame because it's turning, but to good approximation it is. It's not turning very fast. It turns once every 24 hours, as we'll see later in this chapter. Any reference frame that's turning has to be accelerating. But it's accelerating quite slowly, and so to good approximation, the Earth is an inertial reference frame. And with that statement, all frames moving with constant velocity with respect to the Earth are also inertial. And any frame accelerating with respect to the Earth is not inertial. All right.